Hello everyone, my name is Miss Kanau and I'm one of your grade 11 maths teachers. In today's lesson we would be looking at numeracy. Numeracy comes from the word numbers. And what is it? Numeracy is the ability to understand and work with numbers. It is the set of mathematical skills that we used in everyday's life. And the four fundamental operations that we used in mathematics in everyday's life is addition, subtraction, multiplication, and division. And there are many other numbers in the mathematical world that we need to know. And as we go along, we'll come up with those numbers. And there are numbers like whole numbers that you have already learned. There are numbers like natural numbers, even numbers, odd numbers. And people ask, what is odd number and even numbers? Well, even numbers are numbers that are divisible by 2. Odd numbers are numbers that when you divide by 2, you always have a remainder. Prime numbers. What are prime numbers? Well, those are some of the numbers that we'd be looking at and we'd be working with as we go along. And prime numbers actually are numbers that have only got 2 factors. The number itself and number 1. For example, 3. 3 is a prime number. It has factors of 1 and 3. 1 times 3 equals 3. In today's lesson, we would be looking at a special type or group of numbers, and it's called surds. And surds is used with a mathematical symbol, and it's the square root symbol that looks like that. And we'll go straight to look at the 5 main properties. Some people call it rules. I call it property. It is still the same thing. And the first rule of surds would give us to number 1. The square root sign, A is a number and B is a number. What does it mean? It simply means it is the square root of A multiply square root of B. Let's look at an example that involves numbers. To look at an example that involves numbers, we'll have this. If I have a number and it is 50. How do I express it into that form? In order for me to express it into that form, I need to find 2 factors. And one of the factors must be a square number. A square number is when you find its square root, it goes back to the base. So in this case then, the 2 factors would be 25 and 2. The square root of 25 is 5. What does that mean? It means that if the opposite of that means 5 multiply 5, it gives me to 25. And the multiplication sign is omitted, and my answer becomes 5 root 2. That is simplified version of square root of 50. In example number 2, we have a surd rule that gives us parenthesis, square root of A, all of that raised to the power of 2. Let's expand it to simplify and understand it better. It simply means square root of A multiply square root of a, which will give us 2 square root of a squared, and square root of a squared is equal to a. Let's give a numerical example. And a numerical example, if I have root 3, all of that raised to the power of 2, expanded. So we go square root of 3 multiply square root of 3. That would give us to square root of 9, and the value is 3. That is example 2. Let's look at 3. If I have rule number 3 and it gives me a radical sign like that, and it's got a divided by b. The fraction bar, note that it's always used as a division in numeracy. That we need to simplify to understand it better, and it gives us square root of a is the numerator, and the fraction bar, you have square root of b to be simplified. If I have a real example using numbers, and I'd go the square root of 75 on a denominator of 9. Let's express it into this form. It would give us to square root of 75 over a denominator of square root of 9. Simplifying that, we go back to using these. So that would give you to square root of 25. And think of a number that when you multiply with 25, it gives you 75. The answer is 3. All over a denominator of square root of 9, we know that 9 is a square number, and therefore it gives us to 3. Simplifying that, you have square root of 25 equals 5, root 3, all over a denominator of 3, where 3 is a whole number. Let's look at rule number 4. And in rule number 4, we have a root c, adding that onto b root c. A root c plus b root c would give us to a, adding b, all of that times c. That is the rule given to us. Now, let's use some numerical values to test that rule. In that case, then, I've got 3, this is the example, 3 root 7, adding that onto root 7. Take note here, 3 root 7 plus root 7. In maths, when there is no number before the radical sign, it simply means there is a number 1, but normally it's omitted. So if that has to be simplified, it would give us to group 3, which is a whole number, plus 1, all of that root 7. Collecting our like terms, we now have 3 plus 1 root 7. That would give me to 4 root 7. This is an example to rule number 4. Let's look at rule number 5. And in rule number 5, we have a root c subtracting B root C. It's actually the inverse of rule number 4. So that would give us to, if we were to collect our like terms, it would give us to A subtracting B root C. Let's use a numerical example to that. And to have a numerical example, let's put it down here. That would give us to 4 root 11 subtracting 2 root 11. Collecting our like terms, it would give us to 4 subtracting 2 root 11. The difference of 4 and 2 is equal to 2 root 11. And that brings us to the last example of rule number 5 in SEDS. I hope you have learned something and enjoyed the lesson, and I look forward to seeing you in our next lesson, which is on indices. Thank you.